Hello, geometry students. Here we're doing section 4.4 or 4-4, and our new vocabulary is included angle. Okay, we have a side-side-side congruence called SSS, and what it says here is that if you have two triangles and we have three corresponding sides all congruent, then the two triangles themselves are congruent. So if you look in the picture here, we have BA congruent to DE. And then we have BC, segment BC, congruent to EF. And then finally we have AC congruent to DF. And since we have all three sides being congruent, then the triangles themselves are congruent because of the side-side-side postulate. Here we're going to use side-side-side to prove triangles congruent. If you notice right away, it's we only have two sides being congruent. Right? We have UA being congruent to the QD or DQ. Then we also have QU and DA. Now, the important thing is the fact that this side, right, is congruent to itself. And that's called the reflexive property. So we are going to have a third side because they share a side. So here we're going to write a flow proof. And so we're given the following. QU is congruent to AD, and that's based on the two tick marks. And we also have QD being congruent to AU, and that's given in the picture by the single tick mark. And we're trying to prove the triangles are congruent. So our flow proof is the fact that we have the two given statements, and then we can have the reflexive property for that third side being congruent to itself, and all three of those then can point to our final statement of the triangles being congruent based on SSS. Okay, so in this problem, it says which information is missing from the flow proof. Okay, so we have that little question mark. And we know that D is the midpoint of BC. Okay, that's given to us. And we want to prove that ADC is congruent to ADB. Go ahead and stop your video and see if you can decide on which is the missing piece. Good. We could say that AD is congruent to itself because of the reflexive property. So since the reason was below the box, right, we knew what to say above it. And we had to make sure that we had the AD, okay, right here, the AD being congruent to itself because of the reflexive property. Okay. Here we have triangle DVW has those vertices, and triangle LPM has those three vertices, and we're going to graph both triangles on the same coordinate plane. Okay, we're going to use our graph to make a conjecture as to whether the triangles are congruent, and we're going to explain our reasoning. And then third, we're going to write a logical argument that uses coordinate geometry to support the conjecture you made in part B. Okay, so here we go. First of all, here's our graph with the two triangles. Okay, so we end up plotting them. We should make a conjecture that triangle DVW and LPM or DVW is not congruent to LPM. So based on the picture, I would say they look like they're congruent just based on the shape and size of the lengths. Okay, from the graph, it appears that the triangles have the same shape, so we conjecture that they are congruent. Now we're going to use the distance formula to show all the corresponding sides have the same measure. So think about what sides are corresponding to each other. WV definitely being corresponding to PM, right? So here we go. So here we have WD, okay, using the coordinates of W and D, we find the distance or the length of that side is the square root of 13. Okay, DV has a length of square root of 17, so we're doing the triangle all on the left. And then we also have that last side, or the long side, which is the square root of 40. Okay, now we're going to do the same thing on the other triangle. We get the square root of 13, we do get the square root of 17, and we get square root of 40. So WD equals ML, DV equals LP, and VW equals PM. I almost forgot what the letter V's name was. And then by definition of congruent segments, all the corresponding segments are congruent, and therefore the triangles are congruent by SSS. Alright, check your progress. Okay, determine whether the triangles are congruent. Go ahead and stop your video and find the line segment lengths based on the distance formula to decide if these triangles are congruent. And if you said yes they were, you were correct. Now let's show that. Okay, so we have the distance right between the A and the B. So let's go -5 to 0 will be a distance of 5. We're going to square that and get 25. And then the distance from 5 and 3 is a 2. Square that and get a 4. And that's going to get me then the square root of 29 is the length. Okay, now I'm also going to do the same thing for the DE and the F. So the change from 6 to 1 is 5. Square that and get 25. And the difference between a -3 and a -1 is also 2. Square that and get 4. So its length is 29. So I'm doing the corresponding sides. That way, if one of them was different, I could stop. And I wouldn't have to find all 3 sides of the single triangle. So far, we have seen that AB is congruent to the DE side. Okay, so now we're going to do the next side, which is going to be the B and the C. So we're going to see the difference between a 0 and a -4 is 4. Square that and get 16. And then the difference between a 3 and a 1. So here's my 3 and here's my 1. That's a 2. Square that and get a 4. So I got root 20. So we have the length, right, of BC. So this length right here ends up being root 20. Okay, now we're also going to do the same thing for EF. We're going to check this side length and see if it's also root 20. Alright, so the difference between a 1 and a 5 is 4. Square that and get 16. The difference between a -1 and a +1 is 2. Square that and get 4. So indeed it has length 20. So we have that EF is congruent, right, to our CB. And then lastly, we can do the AC side. So we're going -5 to -4. That's a difference of 1. That square gives me a 1. And the difference between a 5 here, right, and a 1 up here is a 4. And we're going to square that and get 16. So I get root 17. So my A to C here and over here is root 17. Now we're going to do the same thing on the last, the DF. And 6 to 5 is 1. Square that and get 1. And the difference between a -3 up here, right, and a 1 is a 4. Square that and get 16. So indeed, all 3 corresponding sides have the same length. Therefore, we have 3 corresponding sides all being congruent. Therefore, my triangles are congruent. Okay, now we have postulate 4.2, and this is dealing with side angle side. So we have 2 sides of a triangle, and then here's that new vocab and the included angle. The included angle between 2 sides is the angle between them. So since we have side length AB marked and BC marked, the angle B would be the included angle. So it's in between. Same thing over here. The included angle is angle E. Okay, so if you have a triangle relationship of two sides, and the included angle being congruent, then the triangles themselves are congruent. Okay, let's see this in action. Well, we have a moth here, and I guess we have a two-column proof to prove that triangle FEG is congruent to HIG. Okay, but we know that EI currently, EI is congruent to HF. Okay, so we know those distances, this distance here, okay, is the same as this distance here. And we also have G is the midpoint of both EI and HF. So we know that this GI is congruent to the GE, don't we? Because of the midpoint, right? Definition of midpoint, they're going to be equal, therefore, by congruence, right? And then we have the same thing here. We have HG is congruent to FG. So remember, we're trying to do this side angle side. See this right here? So, since we have those two sides, then we're talking about this angle, the included. It's the angle in between them. And we know that that angle there has to be the same as this angle over here because they're vertical angles. Okay? So we have side angle side. Okay, let's see what the proof looks like as a two-column proof. Okay, we're given all this information. We're trying to prove the triangles are congruent. Okay, so we have all our information. We can put that all in one line if we like to, and just put the word given on the right-hand side as the reason. And then we have FG congruent to HG and EG congruent to IG, and that's what we said. We said the midpoint theorem. Or we also said the definition of midpoint. Might be a better way of saying it, definition of midpoint. And then 3, the angles are congruent because of vertical angles, and then therefore the triangles are congruent by side angle side. I would probably call this the definition of midpoint right here. Definition of midpoint. Because there's another midpoint theorem later on that's a little different than just saying the two line segments would be equal. All right. So checking your progress here. Choose the best reason to fill in the blank. All right. So why would BG be congruent to itself? Okay. And because if it is, then we definitely have the side, right, as a way to prove this triangles are congruent. But why is BG congruent to BG? Go ahead and pause your video and write down the answer. Good. And if you said reflexive, because when you're congruent to yourself, it's a reflexive property. Okay, we're going to use one or the other, and we're going to write a paragraph proof. Paragraph proof is simply writing down your statements in a logical paragraph to make the proof here. So we're going to prove probably that QRT and SRT are congruent. Now we have parallel sides, right? QR and ST looks like are parallel. Okay, and let's see what happens. We're given that RQ is parallel to TS, and we're also given that RQ is congruent to TS because of a little tick mark. The little arrows there are a way to indicate parallel. Okay, when you have a diagram. Okay. We're trying to prove that Q is congruent to S. Okay, so maybe, right, we can do something with transversal, right, and our two, since we could extend, if we want to, we probably could extend these. So we have parallel sides, okay, and then we have a transversal, right, And so I wonder if we could extend these sides here. Let's see if this helps us. Maybe. Sometimes doing this will help you, and if it doesn't, okay, and then there's no harm, right, of extending sides. So we can kind of make some idea of what we're dealing with. Okay, we're trying to prove that the angle up here, Q, is congruent to the angle down here, or so the angle up there, S, is congruent to the angle down here, Q. Okay, so, and so far all we have, right, is we know that RT is congruent to itself. Okay, so we do have two sides of the triangle. Let's see how the paragraph proof is going to go. Okay, so you can see there is a logical paragraph because R and Q are parallel, right? TS are parallel. Alternate interior angles, QRT and STR. Let's go back. QRT, right? QRT, which is this angle up here, right? QRT and STR, we know those are congruent because those are going to be my alternate interior. Okay? That's QRT and STR. Okay? We also have RQ is congruent to TS and RT is congruent to RT by the reflexive property. Alright, so let's go back to our picture. So we have side here, don't we? We have side, we have included angle, and then we have side. And we have that for both of them, don't we? So the two triangles are congruent, side by side angle side. And anytime you have two congruent triangles, then corresponding, right, corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. So let's look at what we have here. Okay, so since we were able to show that the two triangles were congruent, okay, right here, based on SAS, then angle Q and angle S are corresponding angles, therefore they are congruent based on CPCTC. Alright, choose the correct reason to complete the following flow proof. Okay, why can we say, right, look at that right there, it says DC is congruent to BC. Now look at the top, it does say C is the midpoint of DB. Okay, so is it segment addition, symmetric property, midpoint theorem, or substitution? Go ahead and pause your video and make the choice. Good, midpoint theorem.